There are so many algebraic identities that we learned, and memorizing them can be a little tricky. But there are so many ways that we can actually use to help us memorize them. I'll be discussing some ways that I used when I first came across these identities. So let us start with the cubic identities, and the first one is a plus b whole cube. Now, one trick that you can use here is that the number of terms in its expansion will be 1 more than the exponent. So the exponent is 3, and therefore the number of terms will be 4. Now, since it has plus sign, it is a plus b whole cube, right? So all the terms will be positive. Okay. Now comes the coefficients. So the coefficients are 1, 3, 3, 1. So you can just learn it. The coefficients are in this order: 1, 3, 3, 1. 1, 3, 3, 1 is also the cube of 11. So you can use that to keep this number in mind as well. Now comes the variables. Okay. So the first variable is a, and its highest power can be 3. So let's write a raised to power 3. Then we'll write, for each term, we'll write a raised to power in this decreasing order. The second term will have a raised to power 2. Third term will be a raised to power 1, and last term will be a raised to power 0. We'll do the same with b, but in opposite direction. So we'll start with b raised to power 0, then b raised to power 1, b square, b cube. So this first term, we know that b raised to power 0 is 1. So the first term is nothing but a cube. And second term is plus 3a square b. Third term is 3ab square. And the last term is b cube. We got the identity. But in this identity, we can also just take 3ab common from the second and third term. And then we can write it as 3ab. Inside the bracket, we have a plus b cube. So that is also another way to expand this identity. Now let us look at a minus b whole cube. The entire coefficients and the terms will be same. The only difference will be with the signs of the terms. So since we have negative over here, again we're going to have 4 terms. The signs will go in alternate order: positive, negative, positive, negative. And let's put on the same coefficients and the same variables. So we have a cube minus 3a square b plus 3ab square minus b cube. Again, let's take minus 3ab common. So inside the bracket, we'll have a minus b. Minus minus will be plus, so this will be 3ab square. So this is another way we can expand a minus b whole cube. Now, we just saw way in which we can learn this identity. But let us check if this is right, if what we are being taught is right as well. We can verify it, So a plus b whole cube is nothing but a plus b whole square into a plus b. And expansion of a plus b whole square is a square plus 2ab plus b square. So we'll multiply this entire blue term with a plus b. We can use distributive property over here. We'll first multiply the blue term with a, and then we'll multiply the blue term with b, and we'll add them. So let us do that. This is a into a square is a cube plus 2a square b plus ab square. Then we have plus a square b plus 2ab square plus b cube. Now let's write a cube, and there are 2 terms of a square b. These are the like terms. We'll add them. We have 3a square b. Similarly, there are 2 terms of ab square. Let's add the like terms. We have 3ab square. And then we have b cube. So the expansion is a cube plus 3a square b plus 3ab square plus b cube. Now let us look at one more identity, which is a plus b plus c whole square. Now we have seen the expansion of a plus b whole square. So we'll just use that to get its expansion. Can I write a plus b as some variable, for example, p? Let's just substitute it. So a plus b is p. This identity then becomes p plus c whole square. Its expansion is p square plus 2pc plus c square. Now we'll just substitute the value of p. a plus b whole square plus 2a plus b into c plus c square. Let's expand a plus b whole square, which is a square plus 2ab plus b square, and this will be 2 into a into c plus 2 into b into c plus c square. So let's just collect all the square terms and write them. A square plus b square plus c square plus 2ab plus 2bc plus 2ac. So just like in a plus b whole square, we only had one pair possible, AB, and we just wrote 2 as the coefficient, it was 2AB. Here we can have 3 pairs, AB, BC, AC, and we have written 2 as the coefficient. So this is one way you can use to help memorize this. A square plus B square plus C square, then the 3 pairs, 2AB, 2BC, 2CA. Okay. Now the next identity is a bit trickier. This is A cube plus B cube plus C cube minus 3ABC, and its expansion is a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. Now there is one mnemonic that we can use to learn this. This is 3 cubes unite minus 3 times their bite. Do the sum, then square, subtract pair by pair. So you can maybe just, revise it 2 to 3 times. Close your eyes and then try to recall it. 3 cubes unite minus 3 times their bite. Do the square, then sum, subtract pair by pair. And I can just assure you that you'll learn it in no time. So let us now look at the right hand side and let us try to see if this is actually true. So now we'll multiply the entire green term with A, then B, and then C. We have used distributive property again. So this will give us A cube plus AB square plus AC square minus A square B minus ABC minus A square C. Then we have A square B, B cube, BC square, negative AB square, negative B square C, negative ABC. And lastly we have A square C, B square C, C cube minus ABC minus BC square minus C square A. I'll just see that there are so many terms which will just cancel out. We have a positive AB square and a negative AB square, positive AC square and negative AC square, negative A square B and a positive A square B, then negative A square C and positive A square C, positive and negative BC square, again positive and negative B square C. So what we are left with is A cube plus B cube plus C cube minus 3 times ABC. So let's write it, A cube plus B cube plus C cube minus 3 times ABC. Hence this is verified.